Good morning, class. Today we're going to look at inverse functions and how we write them mathematically. Yesterday we looked at inverse functions in the real world, comparing dollars to pesos and dollars to euros. So today we are actually going to look at inverse functions and what they look like on a graph, what they look like in a table, and even what they look like with equations. Now remember, an inverse function is when two functions, or when one function undoes a second function. So in other words, they're kind of like opposites. It's like the reverse. Someone yesterday in class said inverse functions are like the reverse, when one function undoes a second function. Now there's a few times that we can see this in a graph, and so let me kind of go over this graph right here. This is an inverse function. If you'll notice, we have the function of x and we have a function of g. An inverse function occurs when they reflect over this line of symmetry. So that is when y equals x. So let's go ahead and add that. Y equals x. Now, just to show you what this means, I might be able to help you with some patty paper. So notice here, this is my y equals x. I'm going to sketch this in, and you're welcome to grab some patty paper and do the same. Now, if you'll notice, if I take my f of x, which is my line here, I know your guys' isn't blue, but if I just kind of sketch it, what I'm going to notice is here's my my origin. I can pick up this paper and I can flip it. Oops, I flipped it wrong. Okay, I'm going to go ahead and flip it. And notice, if I line up the yellow with my line, now I have my g of x. So I don't know if that was really easy to see, but notice that when I pick up my paper and I reflect it, it lays on top of the second line. So the function, the blue function here, the f of x, when I reflect it, my line now is the same as g of x. So this is an inverse function. When they can be reflected over this line of y equals x, and the lines match up perfectly, it is called an inverse function. Now something interesting happens with our points. So let's go ahead and start the lesson. I just kind of wanted to explain the graph and what's going on there. So in order to understand how inverse functions work, you need to remember what the domain and the range are. The domain is your x values. They are your inputs. So I'm going to kind of take a look at what my domains are. So my domain are my x values. So all of those are my inputs. Then I have my range. My range are my y values. They are my outputs. So I'm going to highlight those. My range are my y values. And remember, in functions, we sometimes call y f of x. We can rename y in many different ways. So what I'm going to take a look at here, in number 1, they want us to fill in f of x and g of x values in the table. So notice I already have my x values. Now I want to find my f of x values, which is technically our y. Remember, we just use different names. So I notice that negative 7, when negative 7 is, let me go back to negative 7. Here's negative 7 on my x. What is my y value? It is negative 3. You see that? Here's negative 7. Here's my point. This is the point they're asking for. So it is a negative 3. On my f of x line, when I have x is negative 1, I'm going to go to negative 1 right here. What is my y value? Oh, it's actually on the 0. So they want to know what that point is right there. And that is 0. Then they ask me, what is the point at 1? When x is 1, what is the point? And it's right here. 1, 1. And then 3. What's my point that has an x value of 3? So I'm going to go to 3. I'm going to go up to my f of x line. They want to know this point right here. Notice that that is a 2. And then for 5, when x is 5, my y value is right here, and that is going to be a 3. So if I were to graph these points, I get this line exactly. In fact, these are the 5 points. Now in inverse function, we want to take a look at, since g of x is the inverse function, what are its points? And then we're going to compare them. So remember, this is my domain, and this is my range. These are my y values, because we've renamed y as g of x. I know it's funny that we do that in math, but we do. So now I'm looking for my y values. So when x is -3, so remember now I'm on this line, I'm using my g of x line. When -3 is my x value, here's -3, what is my y value? And it is -7. Now I'm going to go to my line and find out what happens when x is 0. So I'm going to stay here, I'm going to go to 0, and I'm going to move down to my line. And I notice that that is at -1. Now I'm going to take a look at when x is 1, when x is 1. So I'm going to go to 1. Oh, it's that same point right there. 1 is 1. Then I'm going to take a look at when x is 2. So when x is 2, my g of x line has a y value of 3. And then when my x value is 3, I'm going to move up to my line, and my y value is 5. Okay, so fill in f of x and g of x values in the table. We did that. Only using the table, identify the following. What is the domain of f of x? Okay, the domain of f of x. Remember, domain is our green, it's our x values. My domain is -7, -1, 1, 3, and 5. Now we got to find our range of g of x. Okay, range is my blue, and I want g of x. So this time they want to know what is g of x, the range. Ooh, look at that. It's a -7, a -1, 1, 3, and 5. What do you notice here? Do you notice that our domain of f of x matches our range of g of x? This happens in an inverse function. Now let's look at the next set. What is our range of f of x? Our range, remember range is blue, range of f of x is -3, 0, 1, 2, and 3. Now they want the domain of g of x. Domain is my x values, and this is my g of x. -3, 0, 1, 2, 3. So, what do you notice about our range of f of x and our domain of g of x? They're the same in an inverse function. So notice that we are really just flipping our domain with our range. Notice that the domain in f of x becomes the range in g of x. The range in f of x becomes the domain in g of x. They basically have flipped, which is interesting because that's what happens here. Notice that I am doing a flip and my lines match up perfectly. So an inverse function is really going to be kind of like a flip. That's how I kind of remember it. Do the two lines reflect over the y equals x? Yes. And we actually did check that with the patty paper. Remember? So here, and grab patty paper and try it. Sketch your line, and then you make the flip, which is called a reflection in geometry. And notice that the lines match up. Okay, so that is one way to look at inverse functions. The second way is to work with our ordered pairs. Now notice your paper has a very, very faint kind of line of symmetry, which is the y equals x. I purposely have it very, very light because I don't want you to confuse it with an actual line. This is just showing you where the flip happens. It's not normally a line on our graph. Okay, so write the ordered pairs for g of x by switching the x and y values of f of x. Okay, so let's go ahead and look at our ordered pairs here. We've got -6, 0, -2, 2. We're going to flip our x and y values, just like we did up here. And then we'll graph them and check them. So if our first one is -6, 0, then in g of x it's going to be 0, -6. Do you see how I flipped? This is x, this is y. This is my new x and my new y, but I'm flipping them. So -2, 2 becomes 2, -2. Then 0, 3 becomes 3, 0. 4, 5 becomes 5, 4. And then 6, 6 stays 6, 6. So I've flipped my values, so now I have inverse functions. These are functions that should undo each other. So let's go ahead and graph the ordered pairs and draw the lines for each function. Okay, so -6, 0. So I start here, I go to -6, and I stay at 0. -2, 2, so I go to -2, up 2. I'm going to do this kind of quickly. If you need to slow down, you can pause the video. 0, 3, 4, 5, and 6, 6. And now I can go ahead and draw my line. Now I'm going to go ahead and do my second one. So I'm going to do 0, -6, and then I'm going to do 2, -2, then 3, 0, 5, up to 4, and then I have 6, 6, and notice that's where they kind of intersect. So I'm going to go ahead and sketch that line. Now remember, you don't have to have a ruler, just go ahead and sketch it just lightly. And we're going to test this. So notice I've graphed it, and we're going to see if it flips over the line. So I'm going to kind of sketch my line of symmetry here, my y equals x. And then I'm going to draw darkly one of the lines I want to reflect. And I'm going to actually pick up my paper. I'm going to flip it. Now make sure you line up that line, and look at that. It matched exactly. So our two lines do reflect over y equals x. So in this case, it is an inverse function.